So here we have a projectile motion problem. So the first thing you want to do in these problems is write down everything you know in the x direction and everything you know in the y direction. So the first thing you see is that delta x, which is the displacement, is equal to 3 meters. While in the y direction, the initial velocity is equal to 0 because the velocity initially is moving in the x direction. So acceleration in the y direction is equal to negative g, or negative 10 meters per second squared. Then we see that the delta y is equal to negative 10 meters because it is going down. And so we need to solve for delta t, which is the change in time, then later plug it into equations to solve for the velocity of x in the x direction. So first we would write down, we solve for delta t. We solve for delta t by using delta y is equal to v naught y times delta t plus 1/2 at squared. We can basically get rid of the first half of the equation because the initial velocity in the y direction is equal to 0. So we are left with delta y is equal to 1/2 at squared. So then we plug it in and we get negative 10 is equal to 1/2 times negative 10 delta t squared. So we can multiply both sides times 2 to get rid of the 1/2, and we are at negative 20 is equal to negative 10 times delta t squared. So then we divide both sides by negative 10, and we are left at delta t squared is equal to negative 20 over negative 10. Or basically delta t squared is equal to 2. So then we want to square root both sides, and we get delta t is equal to square root of 2 seconds. So we found out delta y, but we're actually looking for the velocity in the x direction. So what we're going to do is we're going to plug in the displacement of x over the change in time. And so that leaves us with 3 over 2 meters per second. So our final answer would be 3/2 meters per second for the velocity in the x direction. And that's how you solve a projectile motion problem.